Let's begin our discussion with the same example of furniture dealer. In this example, we observe that the dealer can invest his money in buying tables or chairs or a combination of them. Furthermore, he would earn different profits by following different investment strategies. There are certain overriding conditions or constraints as well. First is, his investment is limited to a maximum of 50,000 denomination, and so is his storage space, which is for a maximum of 60 pieces. Suppose he decides to buy tables only and no chairs. He can buy 50,000 divided by 2500, 2500 being the price of the table. That means he can buy 20 tables. His profit in this case will be 250 into 20, 250 being the profit that he can make by selling one table. That means he can make a profit of 5,000. Suppose he chooses to buy chairs only and no tables. With his capital of 50,000, he can buy 50,000 divided by 500. That means 100 chairs. But there is a storage constraint. He can only store 60 pieces. Therefore, he is forced to buy only 60 chairs, which will give him a total profit of 60 into 75. 75 being the profit he can make by selling one chair. That means he can make a profit of 4,500 by buying only 60 chairs and selling 60 chairs. We are also assuming that whatsoever quantity he is buying, he is selling it all. There are many other possibilities. For instance, he may choose to buy 10 tables and 50 chairs, as he can store only 60 pieces. Total profit in this case would be 10 into 250 plus 50 into 75. That means 6,250 denomination and so on. We therefore find that the dealer can invest his money in different ways and he would earn different profits by following different investment strategies. Now the problem is, how should he invest his money in order to get maximum profit? To answer this question, let us try to formulate the problem mathematically. Let x be the number of tables and y be the number of chairs that the dealer buys. Obviously, x and y must be non-negative, or x and y should be greater than or equals to 0. The dealer is constrained by the maximum amount he can invest, that is 50,000 denomination, and by the maximum number of items he can store, that is 60 items. So when we write these constraints mathematically, it will be converted into equation. 2500x plus 500y should be less than or equals to 50,000. This is the investment constraint. 2500 being the amount in which he buys a single table and 500 being the amount in which he buys a single chair. This equation reduces to 5x plus y less than or equals to 100. There is another constraint that is related to his storage capacity. We will call this constraint as storage constraint. Here we can write it as x plus y less than or equals to 60, x being the number of tables and y being the number of chairs. The dealer wants to invest in such a way so as to maximize his profit. Let's say z, which is stated as a function of x and y or tables and chairs. This profit can be written in mathematical format as equation. Z equals to 250x plus 75y. Here 250 and 75 being the amount that he generates by selling chairs and tables respectively, or to be precise, for selling a single piece of table and a single piece of chair. And this particular function is what we call an objective function. So mathematically, this given problem reduces to maximize z is equal to 250x plus 75y, and this is subjected to the constants 5x plus y less than equals to 100, which is the investment constant, and x plus y less than equal to 60, the storage constant. And obviously x and y should be greater than and equals to 0. So we have to maximize the linear function z subjected to certain conditions determined by a set of linear inequalities with variables as non-negative. There are also some other problems where we have to minimize a linear function subjected to certain conditions determined by a set of linear inequalities with variables as non-negative. Such problems are what we call linear programming problems. There are two methods of solving such kind of problems. One is graphical and another is analytical. The analytical method is also called simplex method, which will be discussed later on in this course. In the graphical method, two variable problems can be solved. With the help of analytical or simplex method, two or more than two variable problems can be solved. We will discuss both the methods in greater detail in this unit.